Okay, in this example, which we'll call 2.3, use the Pythagorean theorem to find the displacement of a car that goes north for 5 kilometers and then east for 3 kilometers, okay? So let's, in terms of drawing things, typically what we do is we put north at the top, we put south at the bottom, we put east in the right, and then we put west in the left, okay? Those are cardinal directions. Now, what it says is, imagine you start right here, you got a car, and you go north for 5 kilometers. So we're gonna go straight in this direction for 5, okay? Here's our starting point. Remember, these are vectors. When we're talking about vectors, we use an arrow to represent the direction that you're moving or the direction of whatever it is you're talking about. Could be a velocity, could be a force, could be a displacement in this case. The arrow is the ending point. That's where you stop. The beginning point is what's called the tail. Then we're going to go 3 kilometers due east. So that's this way. Now notice I'm going to draw the arrow shorter. Why is it shorter? This is 3, right? Remember the length of the arrow, the length of the vector is proportional to the magnitude or the size of what we're measuring. So if I say I go 5 kilometers, I want that arrow to be longer than the arrow that's going, proportionally longer than the arrow that's going to the right, to the east, which is only 3, right? 5 is greater than 3. So the logic that we use here is what's called the head to tail connection. So what I do is I have the tail of the first one going to the end point, which is its head. The tail of the next vector is attached to the head of the first vector. Then what you do is you go head to tail. This is called the resultant vector. And you go from the head of the last vector that you're adding to the tail of the first vector that you're adding. Okay, didn't really draw that quite right. There you go. This is called the resultant vector. Okay, remember, vectors have a length or a magnitude. The length is called the magnitude, and they have a direction. Now, in this particular problem, it's a very specific combination of vectors. It's what we call perpendicular or normal. They are 90 degrees with respect to each other, right? Whenever you do these cardinal directions, so north to east or north to west or south to east or south to west, these are going to be right angles. We have a right angle here. And the right angle, there is a law of mathematics called the Pythagorean Theorem that we can use for that. It works for 90 degrees only. If you have right angle, then the resultant right here, which we'll call, I'll call this one A, and I'll call this one B, and then I'll call this one C. We don't know what C is. That's really what it's asking for us. Find the displacement. The displacement is the sum of those vectors. So if I went this direction, and that direction, and then that direction, and then that direction, you would take your starting point, and you would end up your last point, the last head of the last vector, draw in a vector all the way to where you started. That's called the displacement. It's essentially where you finish minus where you start. Okay, so the Pythagorean theorem is, thousands of years old now. It says that the length of one of the vectors squared plus the length of the second vector that you're adding squared is equal to the resultant vector squared. Okay, so not a plus b equals c, but a squared plus b squared equals c squared. Okay, so we want to find c. So all you got to do to find c is just take the square root of both sides. If you take the square root of c squared, you get c, right? If I take 2 and I square it, and then I take the square root, you just get 2. The square root of the square. It's just whatever is inside the radical. So the first one was 5 kilometers, so 5 squared, plus the second one, which is 3 squared, and you take the square root of that. Okay, so that would be 25 plus 9, right? So that's 36. The square root of 36 is 6, right? Oops, sorry, it's 34. My apologies. 34. So the square root of 34 is a little bit under 6. So for that one, you probably want to grab your calculator and take the square root. You know, if it was the square root of 36, that would be 6. That's a perfect square. But this one's not. So we're going to take the square root of 34. So square root of 34, 5.8. Okay, that's your C. Of course, that's going to be in kilometers. So 5.8 kilometers. Okay, the Pythagorean theorem is used for the combinations of vectors that you're adding when they're at 90 degrees with respect to each other. If they're not at 90, then we have to use other methods. But for this case, which is really the one that we're most focused on, that would be the case. We will use these vectors for displacement, but we'll also can use them for velocity, and we can use them for force. So later in this chapter, we talk a little bit about force, and that's where we'll see that.